And now we want to differentiate secant of x, all right? So I have it here, y equals to secant x. Well, I'll be doing this using the quotient rule, which tells us that if y can be written as a fraction, okay, u over v, where u and v are just functions of x, then the derivative of that y will be, you keep the u, you differentiate you keep the v, which is the denominator, you differentiate u, which is the numerator, right? So you multiply them together, then minus, now the numerator, which is u, times the derivative of the denominator, then we are done with that. Now take it all over the denominator squared, which is the v here squared. Good. Okay, so we'll be using that rule because I'm going to change this function secant squared to a fraction form. Great. So from trigonometric identities, we see that secant is the same thing as 1 over cosine of x. So secant x will be 1 over cosine of x. Okay. So now we have a fraction where I can call this numerator, which is 1, the u, and call this denominator, which is cosine x, the v. Good. So we're just going to apply the quotient rule right here, and let's see what we've got. So the derivative of y, okay, derivative of the function with respect to x will be, now by applying this rule, that is the y, the x will be v times the derivative of u, right? So we have v to be cosine x. So let me just put it down there. V, which is cosine x, times the derivative of u, right? Of u, which is just 1. And then minus, again, u, which is the numerator, times the derivative of the denominator, right? So we put down the numerator, which is just 1, times the derivative of the denominator, which is cosine of x, all right? Okay, and now what we have is just the numerator, and then we have to divide that with the denominator. In this case, it's going to be just v squared. So where v is the denominator, and just square that. So the denominator here is cosine of x, and then we just square that. That will become cosine squared x, all right? When you square the cosine of an angle, you enter with cosine of squared of that angle. Good. Let's simplify things in the, okay, let's differentiate things in the numerator a little bit. Now, we put down the cosine of x times the derivative of 1 with respect to x. Well, 1 is just a constant, and the derivative of constant is just going to give us 0, all right? Then minus 1 times something, just going to be that thing, all right? So the derivative of cosine of x, well, the derivative of cosine x is negative sine x, all right? So we're going to put this down with 1 times negative sine x. Okay, and then we divide everything there by cosine squared of x. Good. And now this is what we've got. 0 times cosine x is just 0, right? Then negative 1 times negative sine x, that becomes positive sine x, because the two negatives will multiply together and give us a positive. And then we have cosine squared x in the denominator. So just put it down there, cosine squared x. Good. Now I'm going to have to rewrite this fraction in this form. I rewrite it as sine x over the cosine of x times 1 over cosine of x. That is just from the fact that this denominator, which is cosine, has been squared, right? Good. And now I can put it down as cosine x times cosine x, just because of it will now sum up the square. So we have sine x times 1 over that, right? Good. So that's just by rewriting the fraction. Now let's see. Sine over cosine of the same angle, the result is going to give us tangent of x, right? That is the trigonometric substitution you make from that. And then we multiply it with, well, 1 over cosine x. Remember what we started with? 1 over cosine x, which is the secant x. So I'm going to put this down as secant x. And that right there is the derivative of secant x, where you need to multiply the function itself with tangent of x. Okay, so that tells us that the derivative of this is tangent of x times secant of x. Okay, great. All right, thanks for watching. Please subscribe to my channel.